We are going to discuss Python today and some common libraries. And for beginners, I would like to suggest the MOOC on the Static platform, Программирование на Python, programming Python. So it's a course for beginners, and as I've told you, it includes problems from the easiest one to quite complex. So be warned. But well, I suggest this course. I also must suggest you the book by Mark Lutz, and there are it's a book for those of you who would like to know Python really well. It's a slow reading, as I would say, with a lot of details and historical info. And also, I must suggest you the courses by the Intellect Foundation. Well, that's because Intellect Foundation provides courses for probably most of the areas of research that are being conducted today in the STEM fields. So, and even some courses, some of these courses are even include basics like applied mathematics or else. And now I would like to ask you, do you know why the Python language is called Python?
It's because of British telly show which is called Monty Python.
Exactly. Thank you. So it's indeed so. As I suppose, the developers really liked the show. Let's discuss the specifics of the Python programming language. Just to mention, so it's a simple programming language because of its unique features. It's a high-level language, and as you see, many Python scripts may resemble a pseudocode that is simple to interpret even by a beginner. So it's dynamically typed, and it represents strong typing. If you like, you can follow links and Google about dynamic typing and strong typing. For now, I just mentioned that for dynamically typed languages, in dynamically typed languages, the interpreter assigns variables at the runtime. So you can see an example of this way of code execution here. So here we have a variable a, and we assign a value, and then we assign a new value of the different type. This may seem simple and may seem natural for someone who hasn't seen, for example, who hasn't seen a code, for example, in Fortran or some other older languages that were introduced in the 20th century. For example, in Fortran, you couldn't do such a thing. So Python is an interpreted language. The source code is translated and putting aside the technicalities, it's executed by the interpreter. Again, that's not a general feature. Some programming languages are compiled like, for example, C or the previously mentioned Fortran. When using a compiled language, after a process called compilation, you have an executable file. For example, you in Windows, if you use a Windows PC, you often execute exe files. So these files are simply called executable. And Python is a multi-paradigm language, so it allows us to use the object-oriented programming paradigm, and, for example, functional programming, and some else. We won't discuss object-oriented programming in detail, but I suggest for those of you who feel who are new to programming to at least search some links about what object-oriented programming is. We indeed will use some code that is written that uses objects and deals with classes. Just as a simple intro, object-oriented programming deals with objects as as you can see, and the main entity in this paradigm is a class. So you can define classes. For example, you can define by considering this pseudocode. You can see that here we define a class professor that has some properties, and from these classes we can instantiate objects that we will then use in our code. Of course, there are some things that you should also consider, like inheritance, encapsulation, etc. And for those of you who would like to get used to with object-oriented programming, I also suggest this course. This course is some kind of a continuation of the previously mentioned one. I suppose you also should follow the courses by the Intellect Fund. However, I cannot suggest you a precise course that would be ideal to get used to object-oriented programming paradigm. Also, I would like to make a disclaimer that we are going to I'm going to give you some kind of a review and give you links to several courses, because we just couldn't discuss all these topics in our course. Just we don't have enough time. Also, I've mentioned the functional programming paradigm, and this paradigm is more, I would say, intrinsically familiar to students who study STEM fields. You also can follow some links, and by following, you can see that functional programming is a natural way to use functions in the code that, for example, can be recursive. So if we would like to compute Fibonacci sequences, we can use such a code, and many else. Functional programming has many advantages, and we will use code that is written in the within the functional programming paradigm as well, and we will do that a lot. So before going to the Jupyter Notebook, I would like to mention also several Easter eggs, the so-called Easter eggs of Python. For example, you can write import this in your interpreter, and you will have the following output. Interesting. And now we have the output. So it's the so-called Zen of Python, written by Tim Peters. It's the philosophy of the Python programming language that lists several principles, like explicit is better than implicit, simple is better than complex, etc. So by considering this list, you can have a feeling that the Python is meant to be a practical language, and it encourages its users to write code that is simple, and it's easily interpreted not only by the Python interpreter, but by other people as well. And the reason for this is simply because code is when you work with some code, you usually read it. So the code, so any code is executed much more often that it is read by people much more often than executed by the interpreter. And here we have, so hence here we have readability counts. And also we have a strange reference to Dutch people. You may also ask why it's so. It's because the Python was developed by Guido van Rossum, a Dutchman, in the beginning of the 1990s. So here I give a link to an interview, to the interview of Guido van Rossum to Lex Friedman. Lex Friedman is a computer scientist that lives in the US. He conducted research in MIT, and after some time he began, some time ago he began podcasting, and he interviews people who share interests with him. Like, for example, he interviews people that work in computer science, and also in machine learning. He is a specialist in computer vision and deep learning. So he often interviews people who work in this field. He also has an interview with Travis Oliphant that I will mention later. So also we should mention PEP8. So what it is? First of all, we should discuss what PEP are. These are Python enhancement proposals. You can Google them. And basically, since the Python is a programming language that is developed by the community, a way to organize the process of development by huge community of people is to write some specifications, etc. So in the case of Python, it's done by issuing Python enhancement proposals. And among all these proposals, most of which are purely technical, you also have step 8. Step 8 is the style guide for Python code that gives suggestions you are encouraged to use when writing Python code. For example, indentation can make a difference when you write code. If done properly, the code is read better. Of course, some indentation practices are strictly forbidden, and the code with wrong indentation so the code with wrong indentation may be quite a problem. And if you scroll and analyze if you scroll and analyze pip 8, you will see that it considers mostly suggestions that simplify, that enhance code readability. So they also discuss should we use steps or spaces, maximum line length, also how should we import libraries, etc. And even despite the fact that I encourage you to use PEP 8, well, I must admit that the code I write the code that sometimes break, that doesn't follow the enhancement proposal, this enhancement proposal. So you are free to polish all Jupyter notebooks I send you for better readability. And also I encourage you to execute the code I provide you at home. And of course, we are going to use Anaconda as a main distribution, as the distribution of Python. And I also should say that it's really much more than just a distribution. It's their package management system for scientific data analysis and computing. By saying this, I mean that it's so widely used that if someone, well, it's almost implicit that people doing machine learning research use Anaconda. Of course, if they use Python or R. Here I suggest you to listen to the interview of Travis Oliphant, who is the founder of Anaconda Inc. Anaconda Inc. Is the company that provides Anaconda distribution for research and for personal purposes, as well as for commercial purposes. So then in the interview, Travis Oliphant discusses the history of Anaconda and discusses many common libraries that we are going to use and we are going to discuss today. So now we are going to execute the code. We are going to consider the Python, the Jupyter notebook I've sent you that features the libraries that I suggest you to use. I shouldn't do that. So Okay. First of all, everyone should install Anaconda if you didn't do that on your personal computer. It's easily Googled. Anaconda is available on the most popular platforms, so everyone can install it. So you can download the distribution from the site and install it. Here I have some guide. This step-by-step guide is written for Linux and Mac users. However, I suppose that many commands should be easily executed on the Windows platform. So by default, Anaconda is installed in your home directory. However, now I've seen some weird behavior of Anaconda that once suggested me to install it in a different directory in the graphic installer. Well, probably this default setting this won't be a default setting. However, we'll see. So if you are using Linux, sometimes shell scripts like the one provided by the Anaconda distributors cannot be executed without changing permissions. Here I suggest you to change permissions by the command change mode 775. However, be warned that this might not be optimal from the security point of view. So if after installing, I suggest you deleting the file. So and I also suggest you avoid using change mode 775. So next, if you use Mac platform or Linux, you need to activate base environment of Anaconda. Here we need to discuss creating Anaconda environments and installing programs, so you can have all the libraries you are going to use on your personal computer or notebook. So I strongly advise you to make new environments upon installation, upon starting your research. If you have a project that implies using some specific libraries, these libraries can have the so-called dependency conflicts. For example, if a library 1 requires other libraries of particular versions, a library 2 sometimes requires different versions of the same libraries the library 1 requires. So I strongly advise you to create new environments, and we will see how can we do that. So you can create an environment. For example, you can create an environment called cheminfo. By executing the following code. So well, in the course of the execution, after hitting enter, you prompted by the managing system to install several the required packages. Here I create a new environment that I easily can delete later, just as a demonstration. We also let's have a short break and wait for the code for the program to execute. Installer.
I have a question.
Yeah.
I'm sure most of the people here use Windows instead of Linux or Mac. What would be the proper procedure for them?
Do you mean the proper procedure for people who use
Windows? Yes.
Or Windows. Windows. So yes, I can suggest you an easy way how to install Anaconda and work with packages that are provided by the Anaconda within the Anaconda distribution. So here, after the install, of so first of all, you download the installer. It's a graphical installer that is simple to use. Next, you should run the Anaconda Navigator program, and here on the Windows platform, you will see blocks in the graphical user interface that will allow you, and some of these blocks. So these blocks allow you to run programs, environments, etc. And among the blocks on the Windows platform, you will see those that run command prompt in Windows. So the procedure translates to Windows easily. You just you should just use the Windows command prompt. Here I have some consoles like Qt console. However, it of course the environment differs from that is installed by default on Windows.
Okay, and I understand now.
Yeah.
Thank you.
Yeah. You should search for the command prompt here. So after the install, you see you can see the you can see several suggested commands that allow you to switch before Conda environments. For example, now I'm in the base environment that is installed by default. However, I can activate the environment I've just installed. So we copy paste the command, and now we see that we are in a new environment. Of course, we can deactivate the newly installed and activate the environment by typing Conda deactivate. So applied libraries like NumPy, SciPy, Pandas, etc. are easily installed in Conda by just typing the following commands. Of course, you can use the graphical user interface by going in this menu. You can install needed packages and libraries.
I have a question. Why would I use an environment when I can just install Anaconda and run it in Visual Studio Code, for example? And it will have all the needed imports and stuff, right?
You can do that by you can use IDEs from JetBrains, for example. It's no problem. However, I use Jupyter Notebook that I'm scrolling now.
I can use this Jupyter Notebook in Visual Studio Code or in my browser, right? So it's not a problem.
You can yes, you can run Jupyter Notebook in your browser. So it's an easy way that I suggest for beginners. And well, I'm just used to doing it this way because Jupyter Notebooks allow you to do well, many things in a convenient way. For example, this is a formatted text. It's human readable, but later we will consider the code to execute, and well, you can combine these two for teaching purposes, and also you can combine Markdown formatted text. So
yeah, I understand.
yeah.
But what is the environment
here?
Like why would I create an environment camo info, for example?
We will discuss that.
Okay.
Yeah. And here, of course, you can install scikit-learn library that we will use for machine learning, and also you can try to install the HDBScan library. That will be used later. And if you try to input this code, without specifying the channel you are using, particularly the CondaForge channel, so you will see that HDBScan cannot be installed from the common channel, and only from the and it can be installed only from the CondaForge. Well, in fact, within Anaconda, you can use many channels from which different programmers or companies or programmer communities provides packages. So some packages are incompatible, and if you have some problems, dependency problems, as I've told you before, with packages, so you won't get far without using separate environments for each. So HDBScan wasn't found in the main channel, so it can be installed only from the CondaForge channel. And here, for example, I provide you a command that does two things simultaneously. So you can create a new environment called demo that in which you can install a package called XTB from the CondaForge channel. The XTB package is provided only from the CondaForge channel, and some libraries, some packages in this channel by installing. So some packages in this channel are incompatible with the packages from the main channel. So, of course, you can get info on environments that have been installed. So if you, as we see, I use several environments for different purposes. And also the base environment is active now. So we are in the base environment. At home, I suggest you to read the text, the step-by-step guide, and install packages that are suggested. So after installing all these packages, you can run the code provided. However, also I suggest you practice a little bit with managing environments. For example, you can share your environment that you are using in a research project with your collaborators. It will simplify the execution of your code by your colleagues greatly. So next, of course, we should install Jupyter Notebook. By default, it is installed in the graphic installer. However, when you create a new environment manually, you will have to install Jupyter Notebook. So this. And we also should install the package called Jupyter Contrib NB extensions. This is the package that adds extra features to the Jupyter Notebook program, and I will show you later why should you use that. So it's installed from the Forge channel. You can also run Jupyter Notebook from the command prompt, and after installing the extensions, you should activate them by doing the following. So you go to the edit menu and you activate extensions that you need to use. I strongly suggest you to activate the following extensions that you can find in the menu for better user experience with Python, with Jupyter Notebooks. I'm going to send you. And let's consider some code examples. Well, here I should beg for mercy of students with beginner skills, because we are going to use quite complex code, complex for beginners, quite complex codes right away. So we begin by importing all necessary libraries, including NumPy, SciPy, Pandas. And also, we are going to use the Plotly library. So we should import, for example, Plotly Express, etc. So now I'm going to show you a demonstration of the code that is related to the tasks, to the problems I'm solving in during research, and we will discuss. So I'll demonstrate you how we can parse and analyze text files using Python. So often you will use the host library, the basic library for work with your file system. I will show you later how it's done. So let's create a list that has codes of different colors. I will show you later why should we define such a strange list. And also let's make dictionaries, two dictionaries that assign different color codes to different elements like hydrogen, carbon, nitrogen, etc. So I give you such a code as an example only, so you are free to modify it, to use it, to adapt it in your research, and you're encouraged to do so. So we also have a dictionary with van der Waals ready of elements. So now let's make some arrays in NumPy. By the way, guys, do you consider the codes I'm showing you complex?
Pretty much, yeah.
Well, it isn't until now. It doesn't seem to be.
So I'm just I just would like to have some feedback to get the level, and if we are speaking the same language. So let's make some arrays. Here we use arange and
sorry, I have a question.
Yeah.
I have a problem.
Yeah.
I have a problem with the code. In chat, you may see the problem. When I try to create an environment.
Yeah, sure. I suggest you installing the XTB package we are going to use later by using the CondaForge channel. And by the way, which operation system do you use?
Windows.
So you can easily get an info on every package that can be installed from main channels. And let's look. So apparently the XTB package is imported to the Windows operating system. Well, that's quite a problem. It won't be a problem for you because we can easily work around the issue. However, it's a shame because as I know, some people ported the XTB program that is distributed within this package on the Windows platform. However, it's for a reason unknown. It's missing in the well, it's missing here. So for now, it's unavailable under the Windows operating system. And if you would like to get would like to try installing some packages the way I've suggested, you can try, for example, this this package. The kit that we are going to use as well. And let's see what we have here. So as you can see, the package is available in the Windows operating system. So I suggest you trying the comments I sent you. I've sent in the chat.
Yes, I tried. That's okay.
Yeah, thank you. So we import of the libraries we are going to use next. We again, we can execute the code, and we can make two arrays, NumPy arrays. So for those of you who are not familiar with the NumPy library, I suggest you completing some basic courses on Python. Well, it won't take much time. So by executing these commands, for example, we create an array with float numbers, so that approximate real numbers, at least rational ones. And we can do rounding to, for example, two decimals easily by executing this line, by including this line in the code. So next, we can, and also I should mention that we use a zip to create a dictionary from two arrays. Zip is easily Googled. And basically, well, it can be used to, for example, make tuples from two lists, and for Okay, and it can be used for our case as well. So next we print some elements of the calibration array. So it contains from the COSMO calibration dictionary. Sorry, it contains float numbers and color codes. So let's here I provide you with a complex function that is used for parsing the file I've also sent you. So here we have a file that encodes a COSMO surface. COSMO surface, we basically we have no need to get in the details of COSMO surfaces. Just in a nutshell, each COSMO surfaces are used to model how molecules to model salvation of molecules, for example, organic molecules. And COSMO surfaces encode polarity of different functional groups that we can that we can find in, for example, organic molecules. So next, we are going to find all COSMO files. Here I use oswalk method, and I suggest you follow the link I provided. So we find all files, and we can print all found COSMO files. You can find them in the zip archive I've sent you. So here, for example, we have the COSMO files that we have found. These COSMO files were obtained via quantum chemical modeling. So they encode molecular polarity for COSMO. For example, here we have more negative group, more negative group. Here we have more electropositive groups. We will use these COSMO files for graphical visualizations. So we found all these COSMO files, and now we can process them using the function I've sent you. By processing these COSMO files, after processing these COSMO files, we can analyze Pandas data frames that were produced by the code execution. So here we have a data frame that encodes that lists atoms in the parameter final molecule. By the way, you can do such things. For example, you can sort the table. Basically, you can sort the contents of this pandas data frame by clicking on the arrows. So this pandas data frame contains atomic position in the Cartesian space, colors, and van der Waals already. So next we can also visualize the data frame PNP COSMO, and I suggest you use using head to visualize huge data frames. So now we have only 5 entries. Oh, so we can beyond 10. We can subset pandas data frames by using a couple of methods. So we can, for example, use log and ilog. Here, let's compare these two data frames. In the first one, we have, for example, an atom number 1, which is in the 4th line. So it has the index equal to 4. And yeah, here. Here we have the Cartesian coordinates. So we just produced a subset data frame from this one, from the larger one. We can also use ilog. However, so it differs a little bit. So you can select by indices. Also, you can slice. You can use slices to visualize the contents of your data frame. The other way. You can use several methods to analyze data frames. For example, you can use value counts. You can use sum. For example, here, what we do have here. For example, here we have 161. What does it mean? It means that in the larger data, in the initial data frame, we have many lines, many rows for every atom. So next, and in fact, if we go and analyze the initial file, here we can see that every atom has many values. For every atom, we have many lines. Next, we can summate, for example, charges. And indeed, for every atom, we have charge. In every row, we can summate them. We can calculate mean values. For every atom, so we have mean value of potential. We can get some statistics as well. So now let's consider the Plotly library, which I strongly suggest. So Plotly is a library for for data visualization, and as a good start, you should try. You should follow this link I've provided in the notebook, and consider examples of using Plotly Express. It's really simple, in fact, and it's much more simple than the code I provide you. For example, you can make scatter plots in Plotly like this. Or you can make more complex plots like 3D plots. Note that I can scroll, zoom in, zoom, and zoom out the obtained plot. So let's make a violent plot with potential distribution for each atom. So in the COSMO file, we have different potential values for each atom. and two different potential values. And we can visualize the distribution by using Plotly. Note that it's highly interactive, so you can analyze data, visualize data with interactive plots. We also can use Pandas to do some statistics on the data frame. For example, we can calculate maximal values, minimal values, means, that for each which every atom has. We can go further and use some advanced functions that allow us to interpolate values. Here I have a function that performs a number of operations, among which it performs a schema interpolation. So it interpolates data this way. In a nutshell, so we do it for smoothing lines and obtain better figures, better plots by using schema interpolation. We, for example, can visualize such a plot that has smooth lines. And here, you should know that as a plotly library allows you to customize your plots in every possible fashion. For example, consider the plot I've shown you before. So let's pay attention to the font used in the figure. Here we have sans. Here we have a serif font, and we can customize the font by assigning different value, for example, to family, or we can customize font. We can enlarge font, etc. So the code I've sent you also allows us to perform to make more complex plots that in which we compare different sigma profiles. So basically, we compare different functions, and also we can create 3D plots with Plotly. Here I also can make a 3D plot like this. It's a 3D plot. And pay attention, note this line of code. I write the plot I've shown you on the disk, and I can open it in my browser. Let me show you. And here we have this plot. You can save it for later and show to your colleagues. To easier, I also should say that you don't need to understand all the codes I provide you now. We are going to discuss the Plotly library later on our workshops,